Okay, now we're going to pick up this review where we left off, and we are looking at a couple of problems where we're being asked to fill in some information about the domain, x-intercepts, y-intercepts, vertical asymptotes. This is a little bit of a typo here. This should also say horizontal asymptotes, as well as this one down here. So vertical asymptotes, horizontal asymptotes, and whether the function is odd, even, or neither. And then kind of come up with a graph of it, a rough sketch at least, that would have the critical information that we would need to know for it. So we're looking at two rational functions. Rational function, again, has a numerator denominator with variable quantities in it. And ours are both polynomials, polynomial on the top and the bottom for both of them. So it's kind of a friendly situation. So the first thing we're going to do is consider the domain, which is essentially asking us what x is allowed to be. And this isn't our first rodeo with this stuff. And so we should be getting the hang of it now that we're looking for numbers that would create zeros in the denominator or negative radicands, you know, what's underneath the radical symbol in an even root power, like a square root or a fourth root or something like that. So if we look at the denominator, it's x squared minus 4x minus 5. So we basically have, you know, x minus 2 over x squared minus 4x minus 5, which factors to x minus 5, x plus 1. And now it's really easy to identify what values would make the denominator 0. So we want to have x avoid being 5 or negative 1, because those would be the values of x. So essentially we're thinking about on a number line, negative 1 would be here, negative 1 would be there, 0 would be here, and maybe 5 would be up here. So we're saying that x can be anything except negative 1 and 5. So knowing that negative infinity is over there to the left and positive infinity is over here to the right, we want to say that the domain is everything from negative infinity up to negative 1 in union with the stuff between negative 1 and 5 in union with the stuff from 5 to positive infinity. So a little secret here, the fact that our domain exists in 3 distinct sections means our graph is going to exist in 3 distinct sections. So that should be something we should look at the end just to make sure it makes sense. Now, x-intercepts are going to occur, this next question, when the numerator is equal to 0. So our numerator is equal to 0 at x equals 2. So that's a spot that we can go ahead and put on the graph right now. And maybe kind of jumping back a little bit to our domain and realizing that x can't be 5 or negative 1, we may as well put up some red walls of death there and here at negative 1. And we could be fancy and label those with their equations, x equals 5 and x equals negative 1, the equations of those vertical lines. So we can put a check mark on that, the x-intercepts. Equations of vertical asymptotes, we now have x equals negative 1 and x equals 5. So let's look for the y-intercept now. The y-intercept, of course, is the spot on the graph where the graph will cross the y-axis. And of course, in doing so, it's going to be on the y-axis. So we're going to say x is got to be 0, because if we were left or right of that, our x value would be something other than 0. So if you just plug 0 into the original function, kind of think about that as negative 2 over negative 5, because if x were 0, all these things would disappear, and you would get negative 2 over negative 5. But there you go. So negative 2 over negative 5 reduces or simplifies to positive 2/5. So we can put a little dot there, about halfway up, a little less than halfway up on the y-axis, halfway up to the first unit. And now we got that done, and we've already got our vertical or asymptotes done. So now horizontal asymptotes. And this is essentially asking the question, what's happening out here to the left as we go toward negative infinity, and what's happening out here as we go toward positive infinity. So to decide that question, we look at the original function, look at the degree of the numerator and the degree of the denominator. And the degree of the denominator is 2, the degree of the numerator is 1. The powers we're looking at right there. If the denominator has a greater degree, without question, the horizontal asymptote is going to be y equals 0. So what I'm going to do is get the idea that if y equals 0 is a horizontal asymptote, that means our graph is going to be leveling off towards 0 out here. So I'll go ahead and put in a little, kind of a green line there and say that our graph is going to level off this way and that way. Now, you may notice I didn't put that line all the way across because it's entirely possible our graph will cross the horizontal asymptote in here toward the middle, because again, horizontal asymptotes are asking what's happening at the ends. It has nothing to do with what's happening in the middle of the graph. And you can see our horizontal asymptote is y equals 0, and we already have a point at 2, 0, so we know that the graph is going to touch the asymptote. But what's going to happen is, as it gets out here to the side, it's either going to come up and level off like that, or come down and level off like that. Same thing over here. It could either come up or come down. So lastly, we'll decide if this function is odd or even, or neither. And so for that, we test to see what f of the opposite of x is. So we would replace all the x's with the opposite of x, minus 2 over the opposite of x squared, minus 4 times the opposite of x, minus 5. And simplify, and we get negative x minus 2, or the opposite of x minus 2, over x squared plus 4x minus 5. We have two negative signs there, which makes it a positive. So that function, I think you would recognize, is neither the same as what we started with, nor is it the opposite of what we started with. Because if it was the opposite of what we started with, every single sign in front of every term would be the opposite of what it is now. Some of them are opposites, that x became a negative x, but the negative 2 stayed a negative 2. So right there it tells you it's neither odd nor even. So we can circle neither. And now we're ready to start graphing. So what we're going to do is consider that we have 3 real critical numbers here, -1 and 5 from our domain being problems, and then 2, which is an x-intercept. We always want to include those those two entities wherever you have a vertical asymptote and wherever you have x-intercepts. And if we look at our function in factored form that we have up here, we have x, well, I don't have to rewrite it, but I guess I will, x minus 5 and x plus 1. We have 3 factors. We've got 1 in the numerator, and we've got 2 factors in the denominator. And what we do is we go along and we test values in this interval. So in other words, anything to the left of -1, for example, -2, if we plug that number in, -2, into this function, the numerator would be -2 minus 2, which would be a negative number. So we can go and put a negative there. -2 minus 5 down here would be negative, and -2 plus 1 would be negative. The fact that we have 3 negatives in a quotient means our quotient is going to be negative. And what that tells us is our graph over here is going to be negative. So all the y values, doesn't matter that we only tested 1, all the y values would be negative. So we can think about how this could work. We've got to level off at that green line, so we're going to be maybe coming up like that. But we also can hit this red wall of death. So it means our graph has to kind of look like that. So I'll go ahead and draw that in there. Doesn't matter, you don't have to be too specific with this, just kind of come in and make a turn. Make it clear that it's going down toward -infinity there and leveling off at 0 up there. Then we can check a number between, moving on to our next section, between -1 and 2. Well, we already did one. We did 0, which is between -1 and 2, and we found we had a positive y value. So that means all the y values between -1 and 2 are going to be positive, so they can be up here. So if we go back and get to our graphing, we say, okay, we can move out here toward the wall, but we got to go up because it has to be positive. We can't turn and go down. And we can come across and touch that guy. And now we'll check and see what's happening between 2 and 5. So I guess we can just put a positive here, indicating that we already knew that section was going to be positive. So between 2 and 5, we could test a number like 3. And if you put a 3 in this numerator, you get 3 minus 2, which would be positive. And so I'll put a positive. And then in the denominator, if you put a 3 there in for this x, you'd have 3 minus 5, which is negative, but 3 plus 1 would be positive. So we have a negative here and a positive here. And we look at the overall quotient with 1 negative in it, determine that it's going to be negative, and realize that our graph between 2 and 5 has to be negative, and if it has to be negative, it's got to duck down and stay away from that vertical asymptote. Lastly, when we switch over to a number greater than 5, so we're looking to see what's happening in this part of the graph, we test a number out here to the right of 5, and everything's going to be positive. 5 minus 2, I'm sorry, something bigger than 5, so like 6 minus 2, 6 minus 5, 6 plus 1. Those are all going to be positive. So we're going to have a positive over 2 positives, which of course will be a positive quotient, which means our graph has to be sitting above the x-axis, and yet it can't crash into the wall, so it's going to have to go up, and our graph is going to look something like this, come down here and then level off at 0 out at the ends. And so there we go. We have a real good picture of that graph, and you could certainly check that by graphing it on Good Grapher or your TI and get that picture. So, we could move on to our second question now, but we covered this one in the class that I taught today. So this should be in your notes. I will, I think, give you, if you want to pause this video, maybe if you didn't try it, or if you missed the class, you can pause this video and try it on your own with all this, with the information x squared minus 1 over x squared minus 9, and realize, and then see how you do, and then I'll draw it in here, everything that's information, all the information that's in there, and then maybe you can check your work with what I have as my final solution. The first thing I would mention, though, is realize the numerator factors to x plus 1 and x minus 1, and the denominator factors to x plus 3 and x minus 3. So you're really going to have 4 critical numbers on this one. Critical numbers, again, are these numbers that make it either the numerator or the denominator 0. They're going to frame your study of this thing to see what's happening between the things like the vertical asymptotes that are going to occur when the bottom is 0 and the x-intercepts that occur when the top is 0. Okay, so there you go. There's the finished product on all this work here as far as what's happening with the factoring, how the denominator is 0 at 3 and negative 3, so that excludes those 2 numbers from our domain. You see the vertical asymptote showing up there. The numerator is 0 at negative 1 and 1, so that's where x-intercepts show up. The y-intercept is 1/9, which you get when you plug in 0 for x's. You're going to get negative 1 over negative 9, which is 1/9, so that's shown there. Not quite to scale, but you can deal with that. And then the vertical asymptote, of course, already shown. The horizontal asymptote, this is one where the degree of the top and the degree of the bottom are the same. So we look at the coefficients out in front, which are both 1s. So the horizontal asymptote is the numerator's coefficient over the denominator's coefficient. That is y equals 1, which is shown there. And I showed that again with the light green line kind of moving out at y equals 1. And then the light green line moving out this way. Again, I didn't continue it through the middle to remind you that every possibility that a graph could always cross over that horizontal line in the center portion of the graph, but it's not going to do it out here at the ends. The function is an even function. When you plug the opposite of x in both for x's, those negative signs are going to get swallowed up by the even powers, and it's just going to be exactly the same as what g of x was originally. So the nice thing about that is you get vertical symmetry, symmetry across the y-axis. So as soon as I finish this half of the graph, you just flip it over and then mirror it over here. I showed my sign chart, the critical numbers, negative 3 being the vertical asymptote, 1 being an x-intercept, negative 1 being an x-intercept, positive 1 being an x-intercept, and then 3 being a vertical asymptote. And testing values in those areas yielded these results. But again, once I did positive, negative here, positive, negative, that means on the other side it's going to be positive, negative like that as well. And then you just get a picture of the graph and you're good to go. So hopefully that gives you a good sense of what you would be asked to do on a test or a quiz with this stuff. And that'll do it. Okay, so now we move into a new realm where we've been given a very detailed description of a function and its graph. And we're being asked to come up with a graph, or at least a graph that meets all these conditions. So for scratch work, I'm going to set up a little coordinate plane over here as we go through each bullet point. The first thing says it's an odd function, which doesn't really help us too much right off the bat, but we know that an odd function has rotational symmetry around the origin. So whatever's up here in this first quadrant will get rotated. There'd be a mirrored image down here in this quadrant. Whatever's in this quadrant would get mirrored up to the first quadrant. So again, that doesn't help us too much now. But it will help us later on maybe to save some time. The function is increasing on negative 2 to 2. That means between negative 2 and 2, this function is going to be moving up as you move to the right. So I might just make a little mark of that. Maybe I'll do it in blue and say, okay, we know this function is going to be kind of trending upwards as we move between negative 2 and 2. All right, and that's about all we can do with that. The function is decreasing between negative infinity and negative 2, so that means all the way over here, this function is trending downward, so it could be coming down like that, could be coming down like that, could be coming down like that, who knows? But it's also decreasing from 2 to infinity, so from 2 to infinity this thing's going to be coming down. So I guess to capture that, I'm just going to sort of go like this and like that. So this graph could look something like that, where it's decreasing, then it's increasing, then it's decreasing. So we've got that kind of covered. We'll see if we need to adjust that later on. This next step, the limit as x approaches negative infinity, so that basically means as you move to the left, our y values are trending towards 0. Okay, so that coupled with this, as x moves to the right toward positive infinity, our y values are trending towards 0. So that means I need to adjust this picture. We can't be decreasing here like this the whole way and still level off at 0. So I'm thinking maybe the only way to really do that would be more like, maybe I'll go a little thicker here, maybe more like that, because now it's going to level off at 0. So maybe this thing looks more like that. Likewise, it's got to level off at 0 on the right side, so maybe it looks more like that. If it's going to decrease and level off, that's pretty much what it would have to do. Because if it's below the x-axis, it can't decrease and still level off at 0. It's got to be coming from above. So hopefully that makes some reasonable sense to you. Let's take a look at what else we have here. So we've covered that, and that. Now we have these one-sided limits. The limit as x approaches negative 2, from that superscript means from the left side, is negative infinity. Well, here's negative 2, and as we come into it from the left side, from the side that's smaller than it, we've got to be heading toward negative infinity. So that jives well with this guy. And it also tells me that is the definition of a vertical asymptote at negative 2. If a graph heads toward negative infinity or positive infinity at a particular x value, that means that x value is a vertical asymptote. So I'll switch over to some red, and I think we can put a red wall of death in there. And now this is not looking so good. It's definitely going to be heading, it's going to be this guy coming down that way. We also have, as x heads toward negative 2 from the right, so that means we're talking about coming in toward negative 2 from the right side. That's what that plus means up there. We're heading toward negative infinity. So that means as we come in here, we've got to be heading toward negative infinity. Well, that works well with this, so we can go with that. So I'm just going to say as we come in here from the right, we've got to be heading down toward negative infinity. All right, so I'll put a little arrow down like that. So that, again, really looks strong for a vertical asymptote at negative 2. Then we have similar information here at positive 2 from the left and positive 2 from the right, except for those two guys, the y values are trending toward positive infinity on both the left side and the right side. So that means we've got to be coming up and going up. So I think we're starting to get a bigger picture that this must have a vertical asymptote at 2 as well. And we now know that this guy, I'm going to go a little thicker again, must be going up like that, and must be going up like that. And so now we have those guys taken care of, and we've got a little more information here that f of x is less than 0 for x's from negative infinity to 0. So that means the y values are negative for everything on the left side of the y-axis. Negative infinity to 0 means negative infinity all the way to 0. Our y values have to be negative. Well, that is consistent with what we've drawn so far. This is certainly below the x-axis, and this stuff here is below the x-axis. I have it drawn up going through the origin right now. And actually, if you peek down here, f of 0 is 0. That means there's a point there at the origin. So I'm going to go ahead and put a point there. And for what it's worth, we also have a point at negative 1, negative 2. So when x is negative 1, y is negative 2. So we got a point there. Maybe I can put those over here as well on the real graph. So the y values are negative to the left of the y-axis, and then this says, I think I have an error here. This should say greater than 0. The y values are positive for x is on the right side. That is my typo. I apologize for that. And that's going to make sure that this thing goes up like that, comes down like that. So I apologize for that. I should have to fix that on my original copy. But other than that little error right there, I didn't even notice that till right now. I was typing this rather quickly. We're going to be good to go. So let's go ahead and transfer this over to the real graph. So we have vertical asymptotes at -2 and 2. And we have a graph that kind of comes up from here, goes up through there. Oh, by the way, the fact that this is an odd function means if f of -1 is -2, an odd function would mean then that f of +1 is +2. When you put in the opposite x value, you get the opposite y value. So I can go put a point at 1, 2 as well, and then follow that guy up. And then we have a horizontal, oops, not up there. We have a horizontal asymptote that we're hitting at 0 there, and a horizontal asymptote at 0 there. And if I want to show off, I can go ahead and put a little horizontal dotted line there to show that. Now, are there other ways you could draw this? Yes, little subtleties, but basically your graph has to have that shape to it. Okay, so we're going to wrap up this review with a little old school algebra. Nothing too new here with the first example anyway, where it says we're going to use either completing the square or the quadratic formula. Quadratic formula is, very basic. You just got to plug and chug. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, of course, a is 3, b is -7, and c is -5. I'm going to go through and use completing the square, which the first thing we're going to do is divide everything by the leading coefficient, which is 3. Minus 5/3 equals 0. And then from that, I'm going to add that 5/3 over to the other side. So I'll come over here and maybe work this first problem. So I'd have x squared minus 7/3 x is equal to positive 5/3. And then the next step is to add half of the linear coefficient squared to both sides. So I'm going to add 1/2 of -7/3, which is -7/6 squared, to both sides, and that of course would be 49/36. That allows me to write the left side as x minus 7/6 quantity squared, and the right side would be the sum of those two, and I'd get a common denom, which would be 60/36 plus 49/36, which is 109/36. So that's equal to 109/36. And then I just need to take square roots of both sides and get x minus 7/6 is equal to plus or minus the square root of 109 over the square root of 36, which is 6, and then just add the 7/6 over and get x equals positive 7/6 plus or minus the square root of 109 over 6. Pretty straightforward there. Nothing new. Now, for 11 and 12, those equations have radicals in them. So what we want to do is, in all things algebra, is kind of isolate the unusual thing. We've got to isolate the radical. So what I'm going to do is subtract x from both sides and be left with x minus 1 equals 7 minus x. And now to get rid of a square root, we've got to square both sides. So essentially I'm coming along and saying I'm going to square this and I'm going to square that. And that's where the errors in these things usually rely. People will square this by saying it's 49 minus x squared or something like that. It's not. You got to think about it as 7 minus x times 7 minus x. It's the most common mistake we have. So the left side just becomes x minus 1, because you're squaring the square root. They kind of kill each other, if you will. And the right side is going to become 49 minus 14x plus x squared. And then we just subtract x and add 1, subtract x and add 1, and we get x squared minus 15x plus 50 equals 0. And take a quick look and realize that there are two things that multiply to get 50 that add to get negative 15, namely negative 10 and negative 5, and we get our solutions of x equals 5 or 10. Now, we got two solutions here, but in plugging them in, it's entirely possible that one or maybe even both of those don't work. Those are referred to as extraneous solutions. And the reason that can happen is when we came in here and squared both sides, we added factors of x to this equation that were not there originally. And with that, you can bring along a solution that wasn't there originally. So by plugging 5 in to the original equation, you'd have 5 plus the square root of 5 minus 1, which is the square root of 4, and see if that's equal to 7. And I think you'd agree 5 plus 2 is 7, so 5 works. And then if we plug in 10, we'd get 10 plus the root of 10 minus 1, which is 9, and see if that equals 7. And 10 plus 3 is not equal to 7, so we cross him out as an extraneous solution. And the only solution we get is x equals 5. Now, the other way you could do that, of course, is graph this on a calculator. Graph that size and that side as like 1, and graph that in y2, and just see where they cross. And you would see they cross when x is 5. Similar for this next one, we have a radical there, so we want to isolate that. So we'd subtract the 2 over and get 3 root x is equal to 2x minus 9. And now we're going to carefully square both sides. And as we square the left side, we're going to get 9x, because we've got to square the 3 and the root of x. And we're going to get 4x squared minus 36x plus 81. And when we set that equal to 0, we're going to get 4x squared minus 45x plus 81. And that would be set equal to 0. So looking at this guy, we have 4x squared minus 45x plus 81. It probably is going to factor. Looks like maybe it's been rigged. So if we check and see if there's 4 times 81, the product of those, if we can find two numbers that multiply to get 4 times 81, that adds to get negative 45. So 4 times 81 is like 2 times 2 times 3 times 3 times 3 times 3. That's 81, and that's 4. So I think if we group this up and maybe do something like 36, which would be 9 times 4 and 9. 36 times 9 would equal the same as 4 times 81, but the sum of those is going to be 45. So we can say this is 4x squared minus 36x minus 9x plus 81, and then factor by grouping, take out a 4x and get x minus 9, and take out a negative 9 and get x minus 9, and then realize that we have 4x minus 9 times x minus 9. So we get two solutions, 9/4 and 9. And I'm going to leave you guys to check and see if those two numbers work by plugging them in. My guess is one of them will be extraneous, and you'll have to knock it out. I have a feeling that 9 is going to be extraneous, because I don't think we're going to be getting... no, actually 9's going to work. 9's going to work. 9/4 might not, though. We'll see. Anyway, that's how you handle equations that have a radical in them. You isolate it and then just square both sides. And then lastly, we have a good old problem involving the division of two complex numbers, going back to P6. So we're just going to multiply by the conjugate of the denominator over itself. So 1 plus I. I think that's supposed to be 1 plus I down there. So we will multiply that by 1 minus I over itself. And the numerator, we're going to get 3 minus 3I minus 2I plus 2I squared. And in the denom, we're going to get 1 minus I squared. And we're going to remember that I squared is negative 1. So that's going to turn that into a negative 2. So we're going to get 3 minus a 2 is negative 1. And then we have minus 5i's. And at the bottom, that is negative 1. So if we're subtracting negative 1, it's like we're adding adding 1. So we're going to get 2. So we could leave the answer like that, or negative 1 over 2 minus 5 over 2i. And there you go. So that's a good batch of stuff to get you ready for this first big test.